In this lecture, we will learn about energy in thermal processes. The image here is taken for a house during the cold season. You can see that the colors of the radiation emitted is dependent on the amount of heat energy being radiated. The windows, the doors will usually emit energy, and here you see their color yellow or orange or red. The ceiling, which has better insulation and there is less energy loss there, it has this blue color. So the type of heat energy emitted depends on the thickness and the properties of the part of the house. In this chapter, we will learn all about thermal processes and what kind of physics is there, what kind of laws are there. Few things to mention here concerning heat and internal energy. When we say internal energy, we are talking about the energy of the atoms and molecules system. On the other hand, heat energy is related to the energy transfer between systems. Usually, the transfer occurs between the system and the environment, and it is governed by the temperature difference. If there is no temperature difference, there will be no heat transfer. So we always require having a temperature difference in order to have a transfer of heat energy. Usually it goes from the hotter object to the colder object. When we study heat energy, we need to understand the unit that we usually use for heat. The unit used for heat is the calorie, and 1 calorie is related to joule, the other unit of energy that we are familiar with from physics 1. 1 calorie is 4.186 joule. We define the calorie as the amount of heat energy necessary to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. Another quantity that we need to learn about when we study thermal processes is the specific heat. Each material has its own specific heat. The specific heat depends on the type of materials and how the atoms and molecules interact with each other. We measure the specific heat by a unit joule per kilogram degrees Celsius. Here we are using SI units. And the specific heat is equal to the quantity of heat per kilogram per degree Celsius. For example, for water, the specific heat is 4,186 joules per kilogram degree Celsius. In plain English, this means you will need 4,186 joule of energy to change the temperature of 1 kilogram of water by 1 degree. In this table, we have a list of the specific heat for some common materials. You can see here that for metals in general, for metals like aluminum, it's 900. For metals, it is smaller than for water. Water is the highest specific heat here, in fact, in this list. Steam is a gas, and again, it has its own specific heat, 2010. Gold, 129, very small. This means you will require energy to heat gold, to change the temperature of gold by 1 degree. So when we solve problems, we always use this formula, and we always need this value, these tabulated values for the specific heat. The energy we use to calculate the quantity of heat is this. Quantity of heat, remember, heat is energy. So this is a quantity of energy. We calculate that from this formula: mass multiplied by specific heat multiplied by the temperature change. For example, if you have half a kilogram of water and you are interested in raising the temperature by 3 degrees Celsius, then we substitute in this formula Q equals M multiplied by C, the specific heat, multiplied by delta T, the change in temperature. The units here are all SI units. We don't need to change anything. So you need just to evaluate this equation. The answer is 6.28 multiplied by 10 to the power 3 joules. 10 to the power 3 joule, we call it kilojoule. So I may speak about this answer by saying it is 6.28 kilojoule. We move on to learn about heat and internal energy. We talked about the heat convection that occurs near the surface of the water in the sea or the surface of the ground. It involves the flow of air current, and the molecules of air will carry the energy with them, the heat energy with them in this process. Check your understanding. Suppose you have 1 kilogram each of iron, glass, and water. Iron, glass, and water. For iron, the specific heat is 448. For glass, it is 837. For water, it is 4,186. And we are told, and all three samples are at 10 degrees Celsius. Rank the samples from lowest to highest temperatures after 100 joule of energy is added to each by heat. So naturally, water, which has the highest specific heat, will change the least. Iron, which has the smallest energy, will change the most. So the slope in this case can be ordered water, glass, iron, because water has the highest specific heat, so it has the smallest change in temperature. Glass is next, and iron is last. Another example, suppose you have 1 kilogram each of iron, glass, and water again, and all three samples are at 10 degrees Celsius. Rank them from least to greatest amount of energy transferred by heat. If enough energy is transferred so that each increases in temperature by 20 degrees Celsius. Again, in order to answer this question, you need to keep in mind the specific heat for iron, 448, and the specific for glass, 837, and the specific heat for water, 4186. So in this case, they will be ordered iron, glass, water, because for a given temperature increase, the energy transfer by heat is proportional to the specific heat.